Welcome everyone. Thank you for joining us at e-KLESF 2022. My name is Sakun from University Tunku Abdul Rahman, Utah. Today we are presenting a webinar titled Huawei FusionSolar Renewable Powered Future by IR Jason Kang. IR Jason Kang is the Smart PV Solution Manager with Huawei Technologies Malaysia Sdn Bhd. Just a little housekeeping before we start. If you have any questions, please type them into the chat box. We will bring them up during the Q&A section at the end of this webinar. All participants, please sign your attendance in the link posted in the chat box. Without further delay, let us turn the time over to IR Jason Kang.
Okay, so I can share my screen now, yeah? Okay, so can you see my screen now, Eza?
Yes, I can see.
So we shall start now, or we shall wait first? I'm ready on my side. You can start now, yeah?
We can start now. Yeah, thank you.
Okay, so good afternoon for those attending. Thank you for this arrangement. I'm Jason Kang. I'm the solution manager for Smart PV. Smart PV, it's a solar solution that we provide to our clients. And I'm representing Huawei Digital Power Malaysia, right? So for today's sharing, let me go through a quick one on the table of content. I'll turn on my laser pointer over here. Okay, so first off is that I would like to introduce Huawei as a company so that you guys have a better idea of what we can provide to our customers. And then second topic would be in regards to solar products, what we can cover. And then I'll be covering for residential solution, CNI solution, as well as the utility smart PV solution as well, yeah. Okay, I had this one. All right, so Huawei as a company, as some of you may have known, Huawei, we are the world leading ICT solution provider. We are known for our products like smart devices, like handphone, laptops. We are also involved in 5G technology as well. And we also provide a smart PV solution or solar solution to our customers as well. So due to these diverse business groups that we have, and also a large business group that we have, as you can see over here, we have covered almost every countries and regions throughout the world. And I would like to highlight here is the number of employees that we have is actually close to 200,000 number of employees. Now, looking at the number of employees, I would like to highlight another point is the employees that we have in R&D. So if you look at the percentage here, is that almost 55% of these employees are actually from R&D. Yeah. So in Huawei, we actually invest very heavily in R&D to strive, whichever business that we venture in, yeah, and to lead the industries that we venture in as well. So as I mentioned, one of the reasons we are where we are today is due to our heavy and also persistent investment in R&D. So for Digital Power Group itself, later I'll go through on what Digital Power is. Yeah. So for Digital Power Group itself, 60% of our employees are actually from R&D. So you can see that our R&D centers are scattered all over the world here. We have 12 R&D centers, and we have invested 10 to 20% of our sales revenue in R&D itself. So over the past 10 years alone, we have invested about 100 billion US dollar in R&D. So that alone surpasses the investment by Microsoft, Facebook, and so on and so forth, right? And because of that, because of our heavy investment in R&D, we have 1,000+ patents all over the world as well. Okay, other than that, we also have a competence center, as you can see here, competence center. For Asia Pacific region, the nearest to us that covers our region for Malaysia would be Thailand, in Thailand, yeah, Asia Pacific Competence Center. So what this competence center does is that it actually work together with the local authorities or regulatory bodies to contribute to the development of the standards, yeah? The global standards, how we can actually safeguard the PV industry, for example. So in PV industry alone, if you look at it for Malaysia, we have this MS 1837 or Malaysia Standard 1837. The current version is 2018. So every 5 years they have to regulate and change up to the standards, the current standards lah. So next year they will revise the MS 1837 to 2023, for example. So we actually work together with these local bodies as well to inform them on the latest technology and contribute to the products updates to these bodies as well. So what we cover mostly will be on the safety. For example, you can see here AFCI or arc fault skin interrupter. Later, I will touch a little bit on this, or RSD. RSD is rapid shutdown, on how we can safeguard the residential and also the commercial industrial buildings clients as well. And then we also grid supporting features, as we may have known, when you have a lot of RE penetration or renewable energy penetration to the grid actually becomes weaker. So how we cater for this type of issues lah. So we work with the local authority regulatory bodies as well. Okay, then ESS, we also have energy storage system. This is our battery system lah. Again, this is more to the safety portion. Okay, so digital power, as you can see here, for Huawei, we have multiple business group. Korea business group is our telco division. We have enterprise, we have consumer business group. Consumer business group covers laptops and handphones and so on and so forth. So digital power group, as you can see here, this is our strategy. What we focus on will still be our fundamental technologies over here, whereby as stated here is power electronics lah. So this is our forte, power electronics technology, digital technology as such, like AI, artificial intelligence technology. So with this strength of ours, we actually venture in these 5 major industry as you can see in this illustration over here. So PV or photovoltaic products is fall under digital power lah. For green power generation. You have smart grid, you have EV as well, electrical vehicle. We also provide the charging module for transportation electrification, as you can see here. And then for green ICT, site power is our off-grid solution. Data centers, smart campuses, and smart buildings. So these major industries actually parked under this portfolio of digital power. Yeah. So as you can see, we actually, with this, all of this in place, we actually can evolve the society from being just a low carbon society to actually achieving the zero carbon target that has been set by our Malaysia government lah, to achieve the carbon neutrality target by 2050, the earliest, right? So now we are living in a world of instant connectivity and also technological advances, as we know. So as you can see, this is the illustration of the industrial revolution, or we call it IR. So we have 2 types of revolution. First off would be information revolution. Yeah, so this is how we deliver the information, via PC internet back then, and then mobile internet, and then of course currently we have industrial internet as well. And the second revolution will be the energy revolution. So you're talking about fossil energy, timber, coal fire, and even now as well, coal fire will still be the major source of the RE mix. Yeah, and with the evolvement of the energy revolution, you can see all over the world, clean energy is the next kind of energy that you should go for. You have, of course, nuclear power, hydropower, wind power, and solar power as well. So hopefully, as you can see from this illustration here, from the first IR it actually, this kind of revolution actually drive the economy. So we have industrial economy, and hopefully we can achieve this digital economy, living in an intelligent world, and of course a greener world, perhaps, yeah, on the fifth industrial revolution. All right, so this is the full products and also solutions that we can provide for a solar scenario. Okay, so these three are the main scenarios that we delegate our product range. First off would be residential scenario. This is, as you can see in the picture here, this is for houses, residents, whereby you can utilize the rooftops. Yeah, we do not manufacture the PV module, but the product range, as you can see in the picture here, battery solution or smart ESS, inverters, smart PV optimizers, the management system, transformer station as well. These are all our product range. Yeah. Residential, we can provide this product range. CNI, we call it commercial and industrial scenario. This is for shopping malls, universities, big factories, and so on and so forth, falls under the CNI scenario, as you can see in the picture over here. Okay, and then we also have for utility scale. Utility scale mostly will cover a ground mounted scenario, as you can see here. We also have a floating solar as well. So the product range for utility is pretty much as you can see over here. Smart transformer station, we provide the whole containerized solution, as well as the inverter. Okay, so let's start off with our residential solution. Yeah. So this is our 1+4+X solution that we provide for residents. We have our main product will be smart energy controller lah, or the inverter. So what happens is that, as you may have known, PV actually produce DC power, right? So DC power will then, DC will then be connected to inverter. Then it will be inverted to AC power, which will be then used for the households. So in Malaysia, it will be 230 volt or 400 volt AC. Yeah. And we also have our smart string ESS. This is our battery solution, which can be coupled together with the inverter over here. And optimizer. Optimizer, I will touch a little bit more on the later portion, which will be useful for safety reason, and also for the increment of the yield, right? And the latest products that we have is our smart EV charger. This is our AC charger, which can be coupled together with the whole ecosystem that we have as listed over here. Yeah, and of course, all of this will be monitored using the smart PVMS or management system that we have. Okay, so what we typically offer to our client will be these four main pillars over here. As you can see, optimal electricity costs, on how you can generate lower cost of electricity. How much is the cost per kilowatt hour? Yeah, we really focus on the optimal LCOE. And of course, a second part will be a safety of the user, and as well as the user experience, as listed over here. So this is the optimizer that we have, which can be installed at the bottom of PV module. So typically, for residential scenario, you might not be able to see this because it's actually installed at the bottom of the PV module. Yeah. So we have two models over here, 450 watt, as well as the 600 watt optimizer. So for our optimizer, it actually can fit, two types of installation scenario. You can put it in a landscape kind of installation of PV module, as well as portrait, because we have a 1.3 meter output cable that suits for both kind of configuration. And with the latest PV module technology out there, there will be an increment of the short circuit current of our optimizer as well, which is 14.5, as you can see over here. So for residential scenario, you can see that there are two types. One is without optimizer, as well as the other one will be with full optimizer. So how is the optimizer comes into the picture is in regards to the safety. Yeah, we can actually have this capability of rapid shutdown capability, whereby I'm going to touch a little bit on that later on. And if let's say your house, you have this chimney or other, or trees beside it, or even a taller building beside it, it actually will create shadow, yeah, shading, as you can see here. So when there's a shadow, it actually will reduce the generation of the PV system throughout the day. So optimizer can come into the picture and actually optimize the yield generation as well. And of course, multi-orientation. Multi-orientation now, you know, for a PV rooftop, you actually have to utilize the space that you have, so you cannot adjust the roof that, the existing roof that has been constructed, right? So with multiple orientation, as you know that, sun, when the sunrise is actually from the west, goes down sunset to the west, right? So the generation will affect in terms of, let's say you have a multiple roof orientation on top of your roof. So with the optimizer installed, you actually can further optimize on that as well. Yeah. Yeah, so this is these are the three common problems that will actually reduce the PV system yield, right? Shading issue, as I mentioned, different azimuth or different orientation, as well as different tilt angle. This will affect the yield performance. So let's take a look at this illustration over here without optimizer. So just imagine all these panels are actually connected in a single string. So when you have shading, yeah, if you can see leaf over here, let's say you have shadow, the current and the voltage of this particular panel will actually drop, right? So the problem will be the current, because if let's say these panels are sharing the same, are configured in the same string, so when the current of this panel drop, it will drag along the other current that is connected to it as well, for the panels that are connected to it as well. So that's why if you look at the formula, is that power equals to current multiplied by voltage, right? P equals to IV. So when I drops, the power will drop as well. So that's why even though these panels are non-shaded, the power will drop, say, to 90%. If let's say you install the optimizer, it will have this function, a buck mode. Yeah, it will then increase the current of the non-shaded panels to be the healthy current, increase to the healthy current level. That's why the P equals to IV formula still applies to here. So even though these panels are non-shaded, the performance will still be 100% with optimizer installed. Okay, so in regards to safety, this is a very good example of what happens, yeah, if let's say you don't have optimizer installed. So let me brief you through the configuration of the installation a little bit. So typically on the rooftop, as you can see the panels over here, you have your string cable. Yeah, this is the DC cable installed. So it will, the positive and negative polarity will be connected to the inverter, which will then invert to the AC voltage or AC power for in-house use, right? So if let's say there's an issue on the rooftop, there's any fault, the inverter will trip, right? Inverter will trip, meaning there's no AC output. But then again, the sun is still there, the irradiance is still there. The irradiance will penetrate to the PV modules and still producing DC power. So whatever power that is connecting to the inverter, before the inverter, there'll still be a DC power, even though there's no AC output. So that's the problem there. If let's say you have fire incidents, so let me play you a video. I don't think you can hear this sound, but this happens in Germany. Okay, so in one of the residents in Germany actually caught fire because of PV system installed. Yeah, so as you can see here, 6 fire engines and 70 firefighters couldn't extinguish the fire due to the energized PV system that is installed on top of the roof. But what happens is that they have to wait for the PV panels to be completely burned down. Yeah, so they cannot, put out fire using water, because as you can see here, the DC voltage in PV system is extremely dangerous for firefighters, and it's actually stated in the firefighters insurance in Germany to not spray water on a PV system, because during the day it will still be live, right? So that's the danger of a PV system installed. So they have to wait for it to be completely burned down. Yeah. Now with the optimizer installed, Okay, let me turn on my pointer again. When the inverter trips, yeah, if let's say there's a maintenance or emergency when the inverter trip or during installation, the output voltage of the PV module, instead of having 600 to 1000 volt DC, for example, it can be reduced to 0 volt. Yeah, so that's the technology that we provide, and it's very safe for the O&M personnel as well as the firefighters to be on top of the roof. If let's say you have a full optimizer installed for the PV system, right? Okay, and this PV, this rapid shutdown capability of ours using optimizer actually comply to NEC standard and also the German standard out there as well. Next, let's touch a little bit on the Smart String ESS. So Smart String ESS, this is our energy storage system compatible to the residential inverters that we offer to our client. So you can see here, it has a very slick design, which is actually inspired by waterfall. Yeah, as you can see in the picture. So no longer you have this bulky kind of battery storage, whereby previously people tend to store the battery storage inside their storeroom, for example. Yeah? So you have this slick design, so it's very nice to look at, right? In regards to the technology that we have, as you can see here, you have your power module here. Yeah, power module is like the brain of the system. It has the BMS capability. It controls the charge and discharge of the battery module. So as you can see here, this is the battery module. So each battery module, the capacity is 5 kilowatt hour. As you can see here, if you have 2 battery modules here, will be 10, and maximum for 1 power module, you actually can install up to 15 kilowatt hour. So if you look at the market out there, we no longer use the capacity of ampere hour or AH. Yeah, so it's in kilowatt hour, whereby it's very easy to be converted and for easier, to calculate it easier lah. Okay. It's very easy. It's a plug and play kind of a battery module. You can install it on the ground mounted, or it can be on the wall bracket. Yeah. So for one inverter, you can have 2 ESS or power modules, as you can see here. So 15 plus 15, that will be 30 kilowatt hour, depends on the capacity or the usage of the house. All right. So each of these battery module, we have optimizer built in, whereby you can have how to say, the battery pack isolation and also auto isolation. If let's say there's a problem with one of the battery module, it can be auto isolated for safety reason. And like I say, it's a plug and play. So with the optimizer built in, you can actually have expansion of the system. For example, you want to install old battery together with new battery. It's very easy with the optimizer built in. And another point will be SOC, or state of charge adjustment. Other technology, you have to adjust the state of charge when you couple with the other battery, whereby the SOC of the other battery is different from this one, for example. But for our solution is that you don't have to adjust it. It will be auto adjust because of the optimizer installed within the battery modules. Yeah. Okay, and of course, in regards to safety, we have 3-layer protection from the battery cell to the battery module, as well as the whole system. So as you can see over here, for the battery cell, we actually use lithium iron phosphate, or LFP. And if you do a little bit of research of LFP, is that in the chemical reaction, it doesn't produce oxygen. Okay, so when you don't have oxygen production, it's very safe lah. As you know, that fire feeds on oxygen. And then on the pack level or the battery module, we also have temperature sensors to monitor the operation of the cell temperature. And if let's say the cell temperature exceeds, for example, 170 degrees Celsius, there's also extinguishing back inside the battery module to actually, for the safety protection of the battery module. And in regards to the system, the whole system energy storage, like I say, if let's say there's any fault for the battery in the middle, it will then be auto isolated, and the other 2 batteries will still be working as usual. And this is actually in compliance to the German standards VDE 2510 over here. So what we're trying to say here is that the battery module is actually very safe to be installed within the perimeter of your house, right? In regards to the battery storage control mode, we have 3 working modes over here. Maximum self-consumption, this is the default mode. So PV energy or solar energy is actually prioritized to be used over the grid energy. So meaning to say, when you have this mode chosen, the energy from the grid will be less lah. Whatever the energy production will be from the solar as well as from the battery itself. So the energy bill will be reduced. So this is applicable in Malaysia actually. And the second control mode will be fully fit to the grid. Whatever the generation from the PV and also from the battery, you actually can sell to the grid as well. So in Malaysia, we have NEM guideline or net energy metering system in place. So you can take a look at it on how we actually can utilize these 2 modes. Yeah. So the third mode will be TOU or time of use. Time of use is very useful if, let's say, you have different tariff during rate during high demand, peak rate, sorry, and also off peak rate. So you charge the battery using off peak rate, whereby the tariff is much lower, and then you sell it back during high or peak rate, yeah, during higher price. So it can make money as well. You can make money out of this as well. But in Malaysia, this is not applicable lah, the TOU. Okay, so we have covered for optimizer as well as for battery. We also have which will be launched, this AC charger. We have 2 types, single phase 7 kilowatt and also 3 phase 22 kilowatt. So we produce this product as well. So for EV battery, for example, if let's say you have 60 kilowatt hour capacity, with our 3 phase 22 kilowatt charger, within 3 hours, you actually can fully charge the car already. All right. So that's the technology that we provide to our clients as well for the residential scenario. All right. Okay, next we have Emma. Emma will be the our AI energy management assistant. We actually integrate this with our FusionSolar management system with the analysis of, as you can see over here, we have data analysis, the meteor data, for example, tomorrow is going to rain. So how the system is able to optimize the operation. Yeah. So with the AI capability, with the MR capability, we actually can prepare the whole system to the best working mode in advance by analyzing all this data, meteor data, the historical data of the usage of the house, and so on and so forth, right? Okay, next would be on the CNI scenario or commercial industrial scenario. We have covered for residential scenario. Next, let's move on to CNI scenario. So for CNI scenario, we also have a bigger optimizer. Just now you saw there's a 450 and also 600 watt optimizer, but it's a bigger capacity, 1001 and also 1003 watt optimizer, meaning to say 2 PV modules to be installed in one optimizer. Yeah. So just now is 1-to-1. This is 2-in-1, and we have our inverter as well from 12 kilowatt AC ranging up all the way to 115 kilowatt AC. And over here, I'll touch a little bit on this as well. We also have battery solution for CNI scenario. For residential, just now you saw that the maximum capacity per inverter, it can stack up to 30 kilowatt hour. But for what we offer to our CNI, the lowest will be 200 kilowatt hour per battery system. Right? Okay, again, let's talk about safety. So for PV system, electrical arcing is pretty common. Yeah. So for arcing, we have 2 types of arcing. We have AC arc. We also have DC arc. And if you look at AC graph, yeah, the sinusoidal graph, you have positive curve as well as the negative curve, right? So in between positive and negative curve, there's what we call zero crossing, right? The zero crossing. So when arc happens in AC system, the arc can be extinguished rather naturally. And furthermore, if you look at it on a global scale, or the global standard IEC standards and all that, the AC system in regards to the protection is pretty mature. You have earth fault protection, overcurrent, and so on and so forth, SPDs and so on and so forth, right? But for DC, it's not mature yet, I would say. And for PV system, it's actually DC powered. So when you have a fault in DC system, it's a direct current. So where there's a fault, as you can see here, the temperature, the arc temperature can reach up to 3000 degrees Celsius. And you don't want this to happen, fire incidents, as you can see in the illustration I've shown you earlier in the residence scenario. All right. So what actually causes this DC arc, as you can see here, is pretty common. If let's say there's unreliable joints within the PV module, this is a manufacturing defect from the PV module, the junction box, it will cause a DC arc. And then if let's say there's a broken PV cable, this is pretty common as well. And the PV connectors, loose PV connectors, as we know that, when you have PV modules installed on top of the roof, there's a vibration on top of the roof, right? So this, as it ages, all these problems will then exist. Then you have this electrical arcing issue, whereby electrical arc will happen and start fire easily, yeah, as you can see in the picture over here. Now let's take a look at what happens in the US. This happens in Walmart stores. So at least 7 Walmart stores actually caught on fire because of PV system from 2012 to 2018. So every year, if you look at the calculation here, every year there's one Walmart store actually catch on fire because of the PV system installed. Yeah. Okay, in their investigation, they found out that what actually started the fire is because of poor installation, and of course there's loose connectors issues, as I mentioned just now, which will lead to this very high temperature. And you don't want to Walmart, the main business is actually below the roof, so you don't want to disrupt the main business that is happening below the roof lah. Okay, and this is another scenario that of course all of us would want to avoid. Yeah, this happens in London, one of the residents. So as you know that your house supposed to be a very safe location for you, especially when you have toddlers, elderlies living under the house. And when this happens, it will cause very high danger to the family members, I would say. So again, the root cause would be because of the loose connection of PV terminals. Okay, so this is pretty common. So for our inverter is that it is equipped with AFCI, or the arc fault seeking interrupter. So these are the problems as I mentioned just now, which are pretty common. So our inverter, yeah, this is the white click on. The inverter is actually packed with power electronics, and we also have AI capability, artificial intelligence, to accurately protect the PV system. So the illustration over here, you see, if let's say there's a PV arc happens in this PV module, whereby this module is connected to the inverter over here. Okay, so with the data analysis using the AI, the inverter will be able to tell whether it's an actual arc fault or it's an interference that is happening within the perimeter of the PV system. And when arc fault is confirmed, the inverter will be turned off less than 2.5 seconds. Now, that is based on the IEC standard out there, 2.5 seconds. The inverter must be turned off via the AFCI function. But for our inverter, it can be turned off 0.5 seconds, yeah, less than 0.5 seconds. So as you can see over here, the standards out there is 80 meter in terms of the PV cable detection range. As the cable, is longer, the positive cable and also the negative cable is longer, the arc signal will actually drop, right? So to detect it, it's harder. But if you look at what Huawei can provide, is that up to 200 meter, our AFCI will be able to detect arc fault, which is 150% better than the standards out there, right? So this is another illustration that we did at actual site. This is when AFCI is disabled. Yeah, we can actually enable and also disable the function. So when AFCI is disabled, as you can see here, we try to create a gap of an actual arc fault. This is a live in an actual site. Yeah, so we create an arc fault. So as you can see, this is a bluish color, and the temperature is 3000 degrees Celsius over, right? And this is what we want to avoid lah. So I will take a look at another scenario of when AFCI is enabled. So this is when AFCI is enabled. Very quick one. There's an arc and inverter directly trip. Yeah. As I mentioned, it can be tripped less than 0.5 second lah. And of course, the accuracy of the detection is, we actually utilize our AI to do this. Okay, so you also have your alarm in your management system, and from the alarm we actually can tell there's a DC arc fault. And not only that, from the alarm you also can tell which is the string of the fault that it comes from. Yeah, so if you take a look at this, when you click in this DC arc fault alarm, you can see that PV string number 2, there's an arc fault, so we can tell up to the level of the string. Yeah. Okay, so again, for our products, we actually, no matter inverter or the battery storage, we actually focus very much on the safety, that comes with it lah. Okay, on how we can tackle all these safety issues. All right, so in regards to the inverter as well, we actually can provide higher yield generation of up to 2% higher in comparison to our competitors, because the MPPT component that we have, in regards to the efficiency is higher. And as you know that Malaysia is pretty cloudy, so when you have cloud and also shading issue, for example, all this MPPT efficiency will take in place. Like if let's say your MPPT is not efficient enough, then you will have a lower yield from the PV system. So we have done a lot of our case study in Vietnam and in Malaysia as well. Based on our comparison, it's up to 2% higher yield generation in comparison to the competitor. Okay, and on top of that, we also have a smart string level disconnector, which is at the bottom over here, the red color one. It's not a isolator, it's an actual, something like a MCB, whereby it can trip on its own. This tripping actually protects from the PV fault as well as the internal fault within the inverter itself, right? And again, it complies to the IEC standard out there, IEC 62548 and also IEC 60947-2. This is our battery solution for the CNI scenario, for commercial industrial scenario. Each of these is 200 kilowatt hour. Pretty much the same kind of technology. We use LFP or lithium iron phosphate as the battery cell. And each of these pack, it comes together with the optimizer as well. So if let's say you have a faulty pack, it will then be auto isolate. If you want to replace it with new battery pack, for example, it's a plug and play kind of a configuration. So there's no need for SOC adjustment as well. And again, in regards to the safety, we also have multi-level shutdown protection and also rapid system disconnection, to isolate if let's say there's any fault in the packs, right? In terms of the alarm, again, we utilize AI function as well, whereby AI function will be able to diagnose, if let's say there's an internal short circuit before it actually happens. This is for the safety for the client. Okay, another technology that we have is the IV curve diagnosis. PV modules, it covers actually PV modules is actually the major component of the system, whereby for the investors, 60% of the initial capex is invested in the PV module. All right, and as I mentioned, Huawei, we do not manufacture the PV module. So PV modules problems are pretty common. You have cell cracks, as you can see in the illustration here, hotspots, PID effect or potential induced degradation effect. This will reduce your yield generation as the PV system ages. corrosion, shattered glass, shading, and all this. These are the common PV problems that will reduce the overall yield generation, right? So for our inverter, it actually comes with this smart IV curve diagnosis. You can see conventional way, they can do it. You can engage your testers to actually perform the IV curve diagnosis. So with this kind of curve, for example, at the IV curve, you can tell, oh, there's a PID effect, there's a shattered glass, and there's a hotspot. But you have to manually diagnose it, and with the testers, they then have to manually analyze the report and perform the report writing. So I've known of a 50 megawatt plant in Malaysia. They took about 3 to 4 months to actually perform the whole diagnosis. But for our online smart IV curve diagnosis, which is actually integrated together with the inverter, for a 100 megawatt plant, within 15 minutes, you actually can scan the whole string. Yeah, so there's no need for the testers to be assigned. So that's how another way we can reduce the OPEX cost to our client as well. Yeah, the online smart IV curve diagnosis. Okay, so that's it for CNI and RESI. The last topic will be on the utility scale. Utility scale would be the large scale solar. Okay, it can be on ground mounted. It also can be for floating solar, FPV. Okay, so for the utility scale, we very much focus on the LCOE, or levelized cost of electricity, in regards to how we can optimize the LCOE. All right. So if you look at the formula of LCOE, is that the overall system must be able to provide a lower capex, lower OPEX. It means your maintenance and also the operation cost must be lower. At the same time, the overall system must be able to provide with a higher yield generation. With that, you can squeeze down the how much money you spend in order to generate a certain kilowatt hour. All right. So these are the pillars that we stand firm on when we provide the solution to our customer. Higher yield generation, smart O&M to reduce your OPEX costs, safety, and also the user uh, uh, friendliness of our products as well. Okay, on how our solution is able to provide with a higher yield is the integration with tracker system. So this is the tracker system, and if you look at tracker system, is that it's actually a motorized solution whereby it is connected together with the table of the PV. So it follows the sun pattern. Yeah, for example, in the morning, the table will be at this angle. So during evening, it will then rotate and follow the sun pattern, as the sun moves from the east to the west, and to get the best yield generation. So for our solution is that we do not manufacture the tracker system, but then we utilize our strength, which is in the AI technology. So we have this self-learning and also optimization feature built inside our inverter again, to have to give a better angle to the tracker. So maybe I'll show you a real case scenario then for you to have a better understanding. So for a sunny day, right? You have this angle, the blue color. Hopefully you can see this SDS, or smart DC system. This is what we can provide. The blue color line over here, and the red color graph over here. This is without Huawei's SDS lah. So a different angle, right? So what happens is that during the day, say 10 a.m., you have these problems. There's a shading, yeah, that occurs because of the this table over here. The shading will be cast here. Yeah, and again in the evening you have the same issue as well, whereby the shading will happen at this particular panel. So when that happens, as you can see, this is the yield graph. Yeah, when that happens, there's a reduction of yield over here in the morning as well as in the evening. Okay, there's a yield reduction because there's a shadow, right? So with our integration, with the integration of the Huawei SDS system, the angle will be, the SDS will work together with the tracker system. Then will communicate with the tracker system to then adjust the angle accordingly to avoid all these problems, or the shading problem, for example, yeah, partial blocking. And with that, you can increase the yield from here. There's a delta over here, yeah, from the morning and evening will then increase the yield that is produced from the PV system. So when you have higher yield, then your LCOE will be lesser. Yeah, your cost of electricity will be lesser. So that's for sunny day. So for rainy day, when it rains, the angle of the tracker will then be close to 0 degree as much as possible to absorb all the irradiance. Yeah, as you know that when it rains, actually there will be the how to say the irradiance will be scattered all over. Yeah, so because of the water particles. This is pretty similar with what we can provide to the residential scenario, residential inverter, as well as the CNI inverter. The integration of IV curve, as I mentioned, that PV modules problems are pretty common. Dust issue, shading, glass breakage, that short circuit. So imagine you have to scan all the performance for all the PV panels over here. So as I mentioned, I've known of a 50 megawatt plant in Malaysia. It took about 3 to 4 months to actually manually scan all of these strings. Yeah, so this is the recognition from our customer in on how we are able to provide them with a reduction of the OPEX cost. Yeah. Okay, let's touch on the safety a little bit. So if you look at the trend out there, the DC current of the panel actually increases. Let's say a power class of 650 watt peak panel, the DC current is about 18 ampere. So when you have multiple strings connected to the inverter, for example, you have 24 strings, the current will be increased to 400 over. So if let's say there's a short circuit within the string inverter, there you go, you have an explosion issue. And this is also applicable to central inverter, which is much worse. Now you have say 200 strings connected to the central inverter. So when there's a short circuit that happens before the inverter, either your DCCB will catch on fire or the central inverter will catch on fire. So what we're trying to point out here is that the traditional inverter is still lacking of this active safety protection, yeah, in regards to the high DC current. So for our inverter, I've shared with you, we have this smart string disconnector as well, whereby it protects from the PV side as well as the inverter side. If let's say there's a short circuit to the inverter, it will be tripped, yeah, for the protection. So unlike for conventional way, if you take a look at 3 years before this, fuse is the solution that people or the industry opt for, yeah, fuse protection. But now we move forward to towards the use of the active smart string disconnector. Yeah, so this is the what we can provide. If let's say there's a PV fault in the DC system, as you can see over here, based on the graph, about 74% of the failure in PV system is because of DC. With our disconnector, we can actually tackle this issue as well. Okay, another technology of ours is that, as you can see, yeah, this is the conventional the problems. DC fault is pretty common, so you have all these hotspots in the DC connectors. This is DC connectors thermal imaging. So when there's hotspot, then the O&M team will then tackle or rectify the issue. Now before that, with the solution of ours, we have all these smart connected temperature detectors. So before the O&M team could actually detect it, our SCTD technology of ours will be able to inform the operation team in this regards, like if let's say there's any hotspots. So it saves them from having a failed inverter, for example. Okay, another technology of ours is that our cooling fan, yeah, the inverter cooling fan. So during the day, the cooling fan will be forward turned like this, yeah, throughout the day. So during the startup of the inverter, it will be auto reverse rotate. So what happens when you have auto reverse rotate, yeah, for a period of time is that the dust accumulated on the blade will be removed automatically. So the cooling effect for the whole inverter will be much better. And this is a TUV report of the availability of our inverter. Based on this verification for a 2.2 gigawatt plant in China, the availability rate of our inverter is 99.999%. Yeah. So this is to show that by using our inverter, the yield increment will be much higher as well. Yeah, because of this verification report. Yeah. So the failure rate will be much lesser as well. Okay. Okay, lastly, I've covered the battery for residential. I've got a battery solution for CNI, and we also have battery solution for the utility scale. Yeah. So for utility scale, each container that you can see in the picture here is 2 megawatt hour capacity, right? So this is very useful if, let's say, as we move towards the high penetration of RE to the grid, it actually will cause the grid to be weaker. So with the BESS or the energy storage technology coming in, we actually can have we can form a grid rather than a grid following a system by the PV, for example, right? Okay, so that's it for my sharing today. I hope I don't bore you too much with the technical information. Yep, so I open to the floor. Any questions, I believe?
Thank you, IR Jason Kang. We will take some questions now. Just a reminder, please type your questions in the chat box. Okay, we would like to take group photo with everyone in this webinar. Please turn on your camera and stand by. Okay, ready? 3, 2, 1, smile. Let's take a freestyle in 3, 2, 1. IR Jason Kang, is there anything you would like to cover before we wrap up?
Nothing from my side. Nothing from my side. Yeah.
Great. Thank you, IR Jason Kang, for this insightful
You're
webinar.
welcome. Yep, no worries. Okay, take care.
Dear participants, please join us for webinar titled An Introduction to Cold Process Soap Making Workshop by GSTS Amelia Chiang Kaman at 3:30 p.m. today. Thank you.